The mighty Roman Empire. At the height of its power, it stretched from the British Isles to the Persian Gulf. Despite existing almost 2,000 years ago, this vast empire was propelled and interconnected by a staggering array of technologies and infrastructure projects that wouldn't be matched for centuries after the empire's fall. Even simple technologies like paved roads were done with such masterful craftsmanship that they lasted far longer than the empire they had been built to serve, and some even still exist to this day. The cities of Rome were served with fresh water from a system of aqueducts, many of which still stand, and public bathhouses provided a level of public hygiene unavailable in most other countries in the world. Technologies we still use to this day had their origins in the Roman Empire, a testament to ancient Roman engineering and daring do. Today, let's take a look at the 5 pieces of technology that helped Rome shape the ancient world.
1, 0, liftoff.
Number 5. Aqueducts. Water. Its importance to an urban population cannot be understated. Without it, society itself could fall apart, and the ancient Romans knew this better than anybody. Enter the aqueduct, vast structures built specifically to carry fresh water to the city's populations. Though the aqueducts were not a uniquely Roman invention, no other civilization built them on such a large scale or used them quite so effectively. Even today, Roman aqueducts can be found throughout France, Spain, Northern Africa, and Turkey. These aqueducts were both public and privately funded, depending on where exactly they led to. Roman emperors themselves would often commission aqueducts as a way of cementing their legacy or to celebrate a great achievement. The city of Rome alone was home to 11 aqueduct systems that supplied the city's fountains and wells with fresh water from almost 100 kilometers away. The first of the great Roman aqueducts was constructed alongside the Appian Way, a long, vitally important Roman road in 312 BCE, and like the Appian Way itself, set a new standard for Roman construction. The famous arches that most people think of when they hear the word aqueduct were only one aspect of the design's secrets to success. In fact, it was a rather small part of it. Aqueducts could reach hundreds of kilometers in length, and only a few of them would even use the raised arches. Surprisingly, the majority more resembled tunnels and canals leading down from mountaintops. They used gravity to transport the water they carried through the natural slope of the land that they rested on. The aqueducts were vital to Rome's success, and one of the reasons they could grow their cities to enormous sizes. Everything from providing citizens with water for drinking and bathing to irrigating fields for growing crops was done through the aqueducts. The network was so extensive and well constructed that it was not until modern times that a similar level of water management was reached in Europe. When the water finally reached a city, it was fed into a large cistern before flowing down into the pipes of the city that would connect to all the major fountains and baths and even occasionally wealthy homes. Remarkably, the famous aqueduct, the Aqua Virgo, was constructed in 19 BCE, but was restored in the Renaissance era and is still, to this day, functioning and providing water to the Trevi Fountain in Rome. And when it was built, this aqueduct was capable of bringing about 100,000 cubic meters of water to Rome every day. Well, these aqueducts allowed city life to flourish as the urban areas could support vastly more people by providing easy access to water sources. At the height of Rome's population, the aqueduct network was capable of providing 1 cubic meter of water per person per day. And all of this was done in an era before powered pumps and electricity. It's truly remarkable stuff. Number 4, roads. Rome is famous for its legendary armies, which subdued enemies on the battlefield with modern tactics that shocked the ancient world. But what good is an army if it takes them weeks to arrive on the scene? Well, herein lies another of Rome's greatest achievements, their road network. See, at the peak of the Roman Empire, there were more than 375 highways built by the state, connecting all the great cities of the empire together. Now, of these, more than 29 led directly into Rome itself, putting the city at the centre of the greatest trade and infrastructure network the world had ever seen. There was more than 400,000 kilometres of road in total. That's 250,000 miles, and over a fifth of it was paved. These roads were extraordinary projects that required the work of thousands of men to build and maintain. Once they were completed, they provided the best transportation network in the world. The roads were built to be as straight as possible to allow for ease of movement, bypassing or overcoming all obstacles in their way. Now, to achieve this, all across the empire, the Romans cut tunnels through mountains and built bridges across canyons. The first of the great Roman roads, the Appian Way, dates back to 312 BCE, and it runs almost 200 kilometres or 124 miles. Now, this was a marvel of ancient engineering, and it served to link Rome with another city in southern Italy, Capua. After the link was established, this city began to grow in importance until it was just behind the Roman capital itself. When the road was extended, it would reach almost 600 kilometres or 370 miles and travel all across the Italian peninsula. Now, this road would be the benchmark for the vast highway network that would crisscross the Roman Empire and form the basis of Rome's authority on the land. Now, the Appian Way and all the later Roman roads were built for 2 lanes at a perfect 4.2 metres or 13.7 feet wide, possibly the first time the construction of roads had ever been standardised. And during their construction, a trench was dug and a foundation of gravel was laid and set between stones lining the path. Now, on top of this gravel, another, finer layer was added before the surface of stone slabs was put down. The roads were built with an inline depression in the centre to allow water runoff, and the roads also had ditches and drains on the side. In addition to all of this, many Roman roads also maintained gravel footpaths running along the sides to allow for pedestrian traffic. Now, some stretches of roads even had service stations for travellers where they could rest and buy supplies for their journey. Now, while the materials we have built highways out of may have changed over the thousands of years since the Romans built theirs, modern road networks can still trace their lineage back to the Roman world. And some stretches of Roman roads still exist for you to walk on today, just like they did 2,000 years ago. Number 3, concrete. Rome is famous for its vast, sprawling cities, which captivated travellers and entered legend with their enormous sports stadiums, theatres, and forums. But at the heart of all this construction was a material you would be more familiar with today and something you might find a bit surprising: concrete. Roman concrete had been developed from earlier examples of the stuff out of Egypt and Greece. The Romans were the first civilization to truly perfect concrete into a stable building material. While ancient Mesopotamian civilizations like the Assyrians and the Babylonians had used clay for the purposes of binding sand and stone into a usable material, the Romans were the first to discover that slaked lime and volcanic ash produced the strongest and most stable material created thus far in history. The volcanic ash, or pozzuolana, was mined near Naples and Rome itself, and it was then mixed with lime before being combined with tufa, tavertine, brick or marble, depending on the conditions. After the discovery of concrete in roughly the 2nd century BCE, the Romans immediately incorporated the material into their buildings. Now, famous structures like the Pantheon and the Colosseum would have been impossible for the Romans to have built if they had not had access to concrete. The great baths of Caracalla and the Basilica of Maxentius and all the aqueducts, roads and bridges built by the Romans that can still be seen today would not have been possible without Roman concrete. Now, indeed, the glittering marble columns and buildings that most people often associate with the Roman Empire were, by and large, simply a covering for a concrete structure. The Romans' discovery and quick adoption of this material provided a strong framework for their monuments and cities and played no small role in preserving so many of Rome's wonders even to the modern day. But how could concrete survive so long in the elements? Today, if we leave modern concrete structures alone, they'll eventually crack and fall apart. Well, this has to do more with what we put inside our concrete today. To reinforce concrete and use somewhat cheaper materials, steel rebar is set inside to reinforce it. But over time, this can admit water, and the steel begins to rust and corrode, and as it does, it cracks the concrete around it, crumbling it into dust. But ancient Roman concrete was so strong that it didn't require any internal reinforcement, meaning that all the concrete structures have survived to this day without cracking or crumbling, which is a truly incredible feat. Number 2, underfloor heating. Now, it might seem like a frivolous modern luxury, but you might be surprised to learn that underfloor heating actually has its origins in ancient Rome. The Roman upper class were nothing if not lovers of luxury, and the idea that they could warm their homes without having to fill them with fires clearly had appeal. The hypocaust, as it was called, was a chamber underneath the floor of a building that allowed the passage of hot air or steam, which would heat the tiles above it and provide warmth to the whole room. The usual design was to lead the hot air from a fire burning by the side of the hypocaust through the building's floor and then out of the chimney in the walls. This would also have the effect of heating the wall itself. And when more warmth was required, more chimneys could open and all the walls of the room, as well as the floors, would be providing warmth. The construction of a hypocaust usually consisted of tiles laid on concrete for the basement, and small support beams would hold up the floor above, usually also built of tiles on a concrete base. The hypocaust was expensive to build, run, and maintain, and so was usually restricted to large public buildings in and around Rome. However, in the north of the empire, around Britain and Germany, where the climate was much colder, the Romans made extensive use of this heating system in almost every wealthy villa. But of course, the poor peasants had just to make do in the snow. Typical. Number 1, plumbing. Rome could funnel millions of gallons of water into its cities. Supplies could come in and out on the extensive road network. Vast, incredible buildings could be made out of an advanced concrete and then heated using underground heating. But how on earth do you deal with the daily amount of waste that massive civilian populations produce? Well, without some serious management, things could easily get out of hand, and the beautiful Roman cities could instead become choked with mountains of human waste. Well, the Roman sewer system was, and remains, famous across the world for its structural integrity and usefulness. Underground sewer systems ran beneath many of Rome's largest settlements, and of course, Rome itself. These sewers kept the streets clean and collected the water runoff from the rain and aqueduct overflow. Even today, the largest of Rome's drains, the Cloaca Maxima, remains structurally sound and works to drain the water from Rome's streets more than 2,500 years after it was first constructed. The Cloaca Maxima began as a simple canal on an existing stream that had been lined with stone. The sewer first served to bring water through the centre of the city, but was covered over in the 2nd century BCE to become Rome's first underground sewer. Now, this once small canal became, over the centuries, the central point of Roman water outflow, with the aqueduct water unused by the Roman people flowing through the sewer and out of the city. Now, this flow of fresh water also kept the sewers remarkably clean, making them easy to maintain. The Romans were understandably proud of this feat of the engineers, and Pliny the Elder wrote in 79 AD that massive blocks of stone are dragged along, they're pounded by falling buildings, the ground is shaken by earth tremors, but in spite of it all, for 700 years from the time of Tarquinius Priscus, the channels had remained well nigh impregnable. He probably never suspected that almost 2,000 years after he even praised the sewer, they would still be operating. Not only was Roman construction more advanced than that of its neighbours, but Roman cities had another advantage. See, Rome was capable of urban planning. The grid system that many cities operate on to this day had its origins in the Roman Empire. This well-ordered city planning likely derives from the army camps that Roman generals had been trained to build. Roman settlements all across the empire would display similar plans, creating a sort of cultural uniformity that would extend the impact of Rome far beyond the lifespan of the empire itself. At the centre of the Roman cities would be the public forum, a place for public events and commerce. And surrounding the forum would be theatres, baths, and other important public structures. Colonnades lined important streets, and water was taken by aqueducts to fountains and public reservoirs to ensure the public had access to clean water. Building codes were enforced, ensuring that new constructions would meet safety standards, would not be built of inferior material that would endanger the city around it. These advanced town planning and construction laws meant that the Roman Empire could sustain a much higher urban population than any other contemporary state. In the 1st century AD, the empire had an estimated urbanization rate of an extraordinary 25 to 30%. Now, for example, the United Kingdom did not reach a comparable rate of urbanization until the 1800s, at the height of the Industrial Revolution. Now, it was a heady time, and the Romans were certainly industrious, but sadly it still couldn't prevent the empire from crumbling. Fortunately today we're left with dozens of fine examples of Roman technology that we can see, and plenty more that we use on a daily basis without even realizing it.